Hello there, and thanks for tuning in to Beach Woodcraft. If you're new here, welcome. If you're returning, thanks for coming back. Today we are going to be looking at engraving this two-layer plastic sheet with text for labels that go on a machine. I'll bring in a piece here that I've cut to let you take a look at it. It's got a layer of black, and we gotta try and focus here. A layer of black on top and white underneath. At least that's the way it's intended to be used. The white is quite a bit thicker than the black. So you just need to take a little bit off and make your text. We're going to be working with Fusion360, and I'll leave that part to the end of the video. If you're not interested in it, you can just skip it. If you want to skip to there, you can do that. I have a bit to change, and I'm going to put this piece down with double-sided tape. When I surfaced this table, it left grooves around the extent of where the machine can cut. And initially I was going to try and mill those down somehow because I didn't like the look of it. But because of the fact that they're square to the direction of cut of the machine, they kind of help line things up. So all I'm going to do is take this straight edge and butt my piece, which I know is already square, up against it. And so it'll be real easy to keep the edges square to the direction of milling. That way when I cut the pieces out, I can just keep everything square and it'll be real easy. Okay, let me change a bit and we'll come back and show you how this all works. Okay, so we're back. We have the bit changed. We have the computer hooked up. The computer did a software update on the G-code sender, so I'm hoping that doesn't throw a monkey wrench in the deal. But we'll see. This piece is double-sided taped down to the bench, and we're ready to home the machine and get started. I'm not going to use dust collection for this operation because cutting this plastic makes little chips. It doesn't really make dust, and it doesn't even throw it that badly. So it's just easier to kind of vacuum it up when it's done, and we don't have all that noise, and you'll be able to see better. So all that said, let's get started on homing the machine. So what I like to do is home all the axes first. And then on this machine, I rehome the Y axes, and that squares the gantry back up to the table. Not sure that homed everything. Let's try home all again. There we go. Okay, it must have already been homed, so it didn't move, and I didn't know what was going on. So we will rehome the Y, and that's a $HY. And if you'll notice, it does one side and then the other side, and so now it should be square again with the table. And for this operation, the material is too thin to use the device that finds the start position. So I just eyeball it. It's never been a problem, and I'm not going to take you through that because it's just kind of boring. I'm going to set the point of the bit up to this left-hand front corner, and then we'll get started. Okay, so I've set the work coordinates 0 point on the front left corner of the stock, and use the, if you ever seen any 3D printing, use the paper method to set the height. So where I just got a little bit of drag on a piece of paper between the point of the bit and my work surface. Then I moved it back up 10 millimeters. I'm ready to hit run, and I'm going to take you in with the phone to get a close-up on the toolpath cutting, and We'll take a look at it when we're done, and then we'll move on to the Fusion 360 part of the process. If you're interested in that, stay with us. If not, thanks for being here. Okay, what did we learn here? As you can see in the close-up shots show, there's some inconsistency in the lettering thickness, and I think that's due to possibly just some inconsistency in the level of my spoil board here. Now it was surfaced with this machine, but I'm noticing that there's some flex here and there, and I don't know if it's possibly moisture has caused it to do a little bit of movement, or possibly something else. But some of the softwares call this V carving when you're using a V-shaped or a tapered style bit. This bit goes to a point, so in order to make the line thickness that your font requires, it drives deeper for that. So if the table is on level, some letters come out thicker than others, and that's unfortunate, but this is a utility machine, so we're gonna go with it. I'm going to cut these tags up into individual pieces on the bandsaw. I'm not going to show that unless anybody, really wants to see it. Let me know. But I've done this a couple of times before, and I used a bit that had that didn't come to a point. It had a 1/32 inch flat, and so the letters were larger though, but it seemed to work better. They were the line weight was much more consistent, but that 1/32 flat was too big for this smaller font that I'm using here on this. So I had to use the pointed bit, and well, you saw the results. So if you're going to do this and you're going to use a pointed bit, you may want to take a piece of stock and put that down on your table first and surface that really, really finely, like a piece of hardwood or something that you know won't move before you make your tags. Anyway, that's it for the practical part. We're going to come back in a few minutes and show you the Fusion360 side of things and some weird stuff that goes on with that. And that'll be it. Thanks for tuning in. So here we are in the Fusion portion of this video. What's kind of sad is that I've been actually working on this all day long, and it's kind of late in the evening now, and I've started over 3 or 4 times because I just can't figure out how to work this software. I hope I have it right now. So here's what we're going to do. First thing we're going to start when we start this new project is we're going to create some parameters to make things more flexible if we ever wanted to change our design in the future. So we are going to call this stock width, and that's going to be 12 inches. And we'll have a parameter called stock length, 24 inches. And a parameter called stock thickness, 3/16 of an inch. We'll also have a parameter called tag length, 3 inches, and a parameter called tag height, 1 inch. That should be all we need. Let's do a quick save. We're going to name our project Plastic Tags. So I saw I made a mistake on one of the parameters. Let's go ahead and fix that before we move on. The thickness is 1/16 of an inch, not 3/16. Okay. So the next step is to create a sketch. We'll create a sketch on this plane. We're going to name this sketch stock. And we will create a rectangle, 2 points, starting at the origin. And this will be stock width by stock length. And we can zoom out, see how it looks. Out is the other way. And that looks pretty good. So we'll finish that sketch. And reorient. And we're going to extrude it into the 3rd dimension with the E key. And this is going to be stock thickness, like that. And our new body is going to be named stock. These names don't have to be unique from one category to the next. Underneath the same folder, they do have to be unique, but not when they're in different folders. So we're going to create another sketch. Create a sketch. We'll select the surface of our existing stock. This sketch is going to be called Grid. We're going to create a line. Here.
I have so many clothes.
And we're going to create another line. Here. And then we're just going to make sure these are in the right place by hitting the D key for dimension. And this is going to be tag length. And this one will be dimensioned as tag height. Okay, so the next step will be to create a rectangular pattern for our grid. And we will set this direction. 3 is a good number. We will set this direction as negative. Tag length. And you can see it created 3. Then this one, we're only going to do 1 of. And we'll do another pattern for this one. Didn't do the pattern. There we go. Pattern. And as you can see, it's not chosen the direction I would have preferred. So we're going to make that 1 in that direction, and then in this direction we'll make it 3, and we'll make this negative tag height. And boom. Okay, and so that sketch is done, and we'll save. Now we're going to create another sketch, which will be the text for our tags. And Fusion is really going slow tonight. Wow. Okay. Super slow. Okay, you have to select a plane, so if you don't, it waits for you, as you just saw. So this will be called text. So we will create text. And the grid is used to specify the alignment for the text. So this will be, and I found that the capital text works best. I'm going to leave this default. height for this one. I'm going to create some text in different sizes to kind of demonstrate how that affects what bit you should choose and what toolpath you should use. This text will be 0.25 inches. Okay. Text. This will be 3/16 of an inch. And then lastly, we're going to create a text that will use a different font. Fusion is just really sluggish. I swear I selected that text. But, alright, so this will be back up to 0.25. But we are going to create a single line text, which everything above this horizontal line is single line text. And we'll see how that affects the process. So, text created. We are going to do a save. Okay, so we're changing from design to manufacture. So this is the CAM part of Fusion 360, or computer aided manufacturing. Our first step is to create a setup. So we create a setup, and that essentially has to do with the machine that we're going to use for this process and the stock that we have. Here is my machine. I'm going to select it. We're going to do milling, stock orientation, box point. The body is here, and our stock, we're going to choose relative mode, but we're not adding. There will be no additional stock. And fixtures if you need vices or hold downs or anything, and those things are just not applicable to what we're doing. All right, our setup is done. So the next step is to create a tool path, which will be a 2D engrave. And in the tool path, the first thing we do is select our tool or our cutting bit. Now, I have two different engraving bits set up in my tool libraries, and we are going to choose, the first one we're going to choose is a 60-degree V-bit with a flat bottom that has a 1/32 inch flat. That's this bit right here. You'll notice it says 30 degrees, but that's half of the V is 30, so the full V is 60. So we select that. That populates all these settings. It's 3-axis machining, and we'll select our geometry. And we are going to select the text. That's what we want to cut. Again, the grid is just used for alignment purposes. Now, the last single line text should not work with a 1/32 inch flat, so we're going to expect an error. Everything else can remain the same. And our toolpath will generate. And you're going to see that there's going to be an error. Open contours have been detected. Try lowering the chain tolerance. But we know that that isn't going to work because of the single line text. So we're going to edit this toolpath. And we'll remove the single line text from the path. All right, let's, that'll regenerate. No error this time. But as you can see, it wasn't, the smallest text didn't get fully engraved. A lot of the letters were too narrow, or the line weight was too small for that bit. So we can do a simulation just to see what it looks like, but you know, we know it's not going to work, or we're not going to get the result that we're looking for. And one of the interesting things is that Fusion tends to do the O's first. The O's and zeros get done before the other bits of the text for some reason, and no matter what settings I've changed, that doesn't seem to make any difference. So as you can see, this tag said Todd Brown. The top of the T is missing. A lot of the W is missing, some of the B and the R. So the result there is not desirable. It's not going to work. For the larger text, yes, it would work, and it would probably be okay. So we're going to exit our simulation, and this was just for demonstration purpose. Edit our toolpath. We're going to choose the other bit. Again, Fusion is just really slow tonight. Okay, so we're going to choose our 90-degree V bit. This is a pointed tip, no flat. But the larger V can make a wider line width without driving as deep into the material, which is also important when your material is only 1/16 of an inch thick. So we don't need to change any other settings. We'll let the toolpath regenerate. And now it looks like everything has been engraved. And we will simulate this. So interestingly enough, it started with the F that time. No rhyme or reason why. And once this finishes, we'll zoom in and we'll see how deep the engraves are and make sure that they haven't gone all the way through. Okay, so we've got a completed engraving, and it all looks good. There's the bottom. Nothing's come through. That's good. When it's sluggish like this, it's really hard to manipulate the model in space, because by the time it starts moving, you've already driven it too far. So that's kind of interesting. But all right. So we're going to do an inspect. Section analysis. Select this face And we're going to drive it in 1/2 inch, so negative 0.5 inches. All right. And I think if I just leave the mouse there, we should be able to see on that face, whoa, how deep everything went. Or not. Huh. Okay, as you can see, the largest text looks like it went maybe close to half of the way through. This spot right here looks like it's maybe even a little more than half of the way through. But I wouldn't have used text that large on these tags. I would have used the 1/4 inch height text anyway. So this all looks good, and if you're not sure, it's always best to do a test on a piece of scrap. Hopefully you've got a piece of scrap lying around that you can do that with. We'll turn off our analysis. And the last thing I want to do is to create a 2D trace. And we will use the same bit and select this last bit of text here, if it lets me. Got it. Okay, everything else remains the same. And that looks good. And we will simulate. And you know, when you're simulating a trace, it's really, really hard because to tell that it's doing what you want. Again, because it's really just scratching, barely scratching the surface. So this is another one where you're really going to want to do a test sample and see if it looks like what you want it to look like. But that is engraving with Fusion 360. If you like this video and this content, please like and subscribe, leave a comment. Let me know if you have experience, if there's things that you would have done differently, or to make things smoother or efficient, or how would you go about this project. Thanks for tuning in, and we'll see you next time on Beach Woodcraft.